Okay, for today's T-notes, we will be talking about thermal energy, also known as heat energy, temperature, and expansion, the differences, the definitions, what they are. Let's get started. So you don't have to copy this, but we're just going to take a flashback on maybe what you've already known about solids, liquids, and gases. All matter has atoms, and atoms move even though it doesn't seem like they are. So solids also have atoms that are constantly vibrating. And this motion is what gives the object a certain amount of energy. We call this the kinetic theory of matter, where all of the particles that make up matter are constantly in motion. Solids are vibrating, liquids are flowing, they're slipping and sliding over each other. Gases are moving completely free, and plasma move incredibly fast and very free. So if you're looking here, even though the molecules are tightly packed together, they are moving back and forth, whereas with liquid they're rolling around, and in gas they're more free, and then even more free and more hectic in plasma. Notice here that the temperature or energy increases as you go from solid to plasma. Remember that thermal energy is based off of the movement of particles, those atoms. It depends on the speed of the particles, the number of the particles, and the type of particles. The more movement that exists, the higher the thermal energy of that object. We have different kinds of heat, and this can naturally occur from the sun, the interior of the earth with the hot molten rock or lava or magma. Heat can also be given off from chemical reactions, such as when we burn fuel or when we are doing respiration or metabolizing, such as when we're breathing oxygen, we burn the food that we eat. And then there's also mechanical actions, such as when you're rubbing your hands or that there is friction. Electrical energy, such as appliances, can create heat, and also nuclear energy can create massive amounts of heat. Temperature is different from heat or thermal energy. Temperature is the measure of the average kinetic energy of all the particles in that object. It is taking a measurement of how active the particles are. The atom's mass and speed determine the temperature of the object. We have 3 different thermometers down here which show various units of measurement for temperature. And here we have Fahrenheit, Celsius, and Kelvin. And notice that where water freezes, it is 0 degrees Celsius, or 32 degrees Fahrenheit, or also known as 273.15 Kelvin. Water boils at 100 degrees Celsius, or at 212 degrees Fahrenheit, or at 373.15 Kelvin. Absolute zero is down here, and we have absolute zero as being 0 Kelvin, but negative 273.15 Celsius and negative 459.67 degrees Fahrenheit. When discussing heat and temperature and how heat transfers, one of the things we need to talk about is the direction that heat flows. Heat always flows from an area that is hot to an area that is cold. This helps us to understand then how a thermometer works. How is it possible that a thermometer can measure heat? Taking into account what we've just taken notes on, saying that heat moves from an area of hot to cold, a thermometer has liquid inside. When that thermometer is placed inside a liquid that is hotter, then what happens is that the heat flows between the 2 liquids from the hot to the less hot, which is inside the thermometer. And what will happen is that the 2 liquids will become the same temperature, which means that when the heat is absorbed, the temperature inside of the thermometer will then rise. Therefore, the temperature will rise, and it will be measured in degrees Celsius. Now, what happens when heat is absorbed by solids? The molecules become excited. So the heat is transferred from outside of the object into the molecules of the object, and the activity begins to rise. The temperature then begins to rise, and if it is high enough, if the energy level is high enough, then that solid will melt to a liquid. For example, we can see this when we cook, and this is a chemical change. When a liquid absorbs heat, the molecules become even more excited. The temperature again rises in the liquid, and it can begin to boil and go into gas, which is known as evaporation. When a gas absorbs heat, the molecules again become excited. Therefore, the temperature rises in the gas, and the gas expands. Understanding that when heat is absorbed by either a solid, a liquid, or a gas, which causes this expansion, this is important because we use this information in everyday life. For example, we can see that on bridges that there's this grating here. So when it is cold, the bridge can condense and collapse on itself. But then on days when it's really hot, then the bridge can pull apart from each other, and it allows this push and pull, this expansion and contraction. So then that way the road or the bridge or the structure does not get damaged. If you've ever had problems with opening up a lid, if it's a little difficult, put the jar underneath the water that is hot for just a few seconds, and then go ahead and try to open it. And what it will allow you to do is the molecules of the metal will start to expand and become a little bit larger than that of the glass. And so you will be able to easily, or at least more easily, open the jar. Here we have a diagram, very simple, classic diagram of phase changes. And here we have solid going to liquid, which is called melting. We have liquid getting more heat absorbed, which then will become evaporation and going to gas. Here we have gas. If it's losing heat, then it will condense into liquid. And if it loses more heat, then the liquid becomes solid. Here we also have where gas and solid can go back and forth between the two when the heat exchange is more rapid than between solid and liquid. Here again is showing solid going to liquid and gas, and then gas going to liquid and solid. And the main thing I want you to know is that when there is more heat absorbed and present in the system, the molecules will get more excited and then jump to the next phase. And when heat is lost and not in the system, then it gets colder, therefore moving from gas to liquid to solid. Now we understand that heat is transferred. Heat can be absorbed, heat is lost. How is it transferred? It's transferred in three ways. It can be through conduction, convection, and radiation. Conduction is the first way that heat can be transferred. It is the transmission of heat from particle to particle. And this can occur when one part of the object has a higher temperature than the other part. And this is when heat transfers from hot to a colder part. If you look over here, one of the examples is that heating a metal rod, the end over here that's in the heat source will become hotter first. The particles on the end of this rod will become more excited, and as they get more excited, that energy is going to be moving through those particles, which will then excite the particles next to it, which will then excite the particles next to it, which will then excite the particles next to it, until eventually you will feel the temperature warm on this side than it was before. Here's a close-up of what this looks like. If you have a heat source on an object, here is a solid, here is the microscopic view of the particles, and this down here is the blown-up version of each of the atoms in the solid matrix. Where the heat source is on this molecule here will start to get more and more excited and start to vibrate stronger and more frequently. This in turn will then domino effect and make these other molecules over here start to vibrate. And when these start to vibrate, then the other nearby molecules will start to vibrate. And so what happens is the heat, the energy starts to go outward from where the original source of heat is. Convection is the second way that heat can be distributed, and convection is where heat energy can be distributed by either liquids or gases, and these are the molecules that are in the liquid or the gas, and this causes a circulating kind of behavior. For example, we see this with wind currents and with water currents. In this example here, I'm showing a wind current. So in the daytime, the land gets hotter than the water, and so therefore the molecules of air above the land are warmer and then move from an area of warm to cold. In the nighttime, however, the land cools down faster, and so the air above the water is warmer. So now we have a sea breeze coming in, right? So we have the air going from warm to cold, and so that's why you have a sea breeze. You have the air that is warm coming into the land, which is then pushing the cool air from the land into the area above the water, which will then get warm and then causes this current. Here we also see the shifting of water that is moving from the equator that is getting warm and then going upwards towards the poles of the earth where it will get cool. And so you have this movement of hot to cold, which then pushes the cold water down, and then when that cold water gets down to the equator, then it gets warm and then keeps this cycling of water from warm to cool. It happens in the other direction too, where you have the hot water from the equator going down to the South Pole and then pushing the cold water up to the equator, and it just continues with these little pockets of currents. Radiation is the third way that heat is distributed, and this is the way that heat is transferred by the use of electromagnetic waves, or EM waves, which is what we know, for example, when the sun is shining. So how the sun gets to us is through EM waves, and it doesn't take a medium in order for that sunlight to reach us. But that is radiation. We can also have radiation lamps or heaters also, which give us that source of heat. Many of us have experienced this. Some of us might not have thought of it, but you do know this, that there are certain colors that can absorb heat, and there are certain colors and materials that will reflect heat. And those colors that absorb heat best are dark, matte materials. The characteristics of bright and shiny materials reflect heat more. And so if you have, for example, blonde hair or light colored hair versus dark colored hair, if you've both ever went outside in the sun for a while and touched the top of your head, you'll notice that the person with the darker hair will feel hotter. And that is because the darker colors will absorb heat better. All right, we've reached the end of our video T-Notes. Thanks for watching. Be sure that you understand all this information and can apply it in our next class.